Hello! Today's video is going to be about handling data and we're going to be looking at mean. So mean is the average that you're probably most familiar with, and it's the one that is commonly remembered the most from school. And this is the average where we add all of our values together and then divide by the amount of objects that we have. So let's have a look at an example. Here is some data that we can run an average on. The question says, what was the average amount of salon appointments? In this sort of question, again, this is why I know it's a mean, because usually if it's the other type, they will state it, or they might even ask you what is the most appropriate average to use. But for the purposes of the video today, I'm doing mean, so that's what I'm going to run. So I know that to calculate a mean, I need to add it all together and then divide by how many I've got. So let's get started with that. You can see I've got my table here, and I can choose now to add them together. Now, some people in an exam, you'll see that they'll start going 1 plus 6 plus 7 plus 6, and they'll write all the numbers out and then do one long addition. That's absolutely acceptable if that works for you. As long as you're accurate, it doesn't matter. I'm not very good at lots and lots of numbers together. I tend to make silly mistakes. So what I would do with this is I'd either add the rows and then you've only got 3 numbers to add together, or I would do the columns. I'll probably do the columns on this occasion. So I know double 8 is 16, add a 1 makes 17. I know 6 and 6 is 12, 6 and 7 is quite near that, that's called a near double. So 12 add the 1 is 13, add the 5 is 18. 7 plus 2 is 9, add the 3 is 12. 6 and 4 are a pair that make 10. If you have children, you might know those as number bonds to 10. Add the 3 is 13. And I'm going to pop that into a column addition now. So I'll start with my 18, 17, 12, 13. Based on the values I've got and the numbers I've been given, I would not expect to have a calculator for this sort of question. So that's why I'm doing this without the use of a calculator. So let's add them together. 8 plus 7 is 15. Add the 2 is 17. Add the 3 is 20. So there's no ones or units if you're a dinosaur like me. Carry 2 tens. There's 1, 2, 3, 4 tens. Add another 2 tens is 6 tens, which gives us an answer of 60. And to calculate the mean, I just now need to divide by how many people, how many appointments, whatever objects we've got, how many of them are there. It's 3 rows of 4. I know 3 4s are 12, so I'm dividing this by 12. If I wasn't confident in my 4 times table, I could just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's absolutely fine too. As long as you get the right calculation, it doesn't matter. So 60 divided by 12. I know the answer to this mentally purely because I did a lot of times tables as a child at school, and I'm quite confident with my 12s. Someone who wasn't confident with their 12s might not be able to jump to the answer straight away. So a method that you may have been taught at school is the bus stop method, where you draw the amount under the bus shelter and how much you're dividing it by. But in doing this method, what you might find is actually you end up in exactly the same position as what you've got here. So how many 12s can I fit in 6? Well, none. How many 12s can I fit in 60? Well, that's exactly the question that's going on here. So another method you can call upon here is something called chunking, which is where we use our multiplication facts to get to the answer. I know perhaps what 2 times 12 is, so I could write the number that I'm aiming to get to and writing 2 times 12, which is 24. Take that off 60. I end up with the answer 36. Okay, that's great. How many more 12s can I fit in there? I know another 2, I could use my doubles again, so I could take off another 2 times 12, take off another 24. 36 take away 24, could even do it like this. 6 take away 4 is 2. 3 take away 2 is 1, that leaves me with 12. So to get me to 0, I'd do 1 times 12 is 12. Take away the 12 gets us to 0. And then it'd be a case of looking at how many multiples did I use, which is 2 plus 2 plus 1, which is 5. So my answer is 5. But like I say, due to the amount of times tables tests I had to do at primary school, which which if anyone listens to this video, if you ever had to do weekly times tables tests, they are, as a child, I don't think you ever forget them. And I remember 12s was the one that I really hated. So I think that's possibly why it sticks with me now. But I know 5 times 12 is 60. But I also used my chunking to get there. So if you weren't confident in that, that is a method you can use. So the answer to this, the average amount of salon appointments is 5. Let's have a look at a different type of question. So this is a question I've seen at level 2 functional skills, and the learner is asked to compare 2019 data, 2020 data, and what you'll find is the second set of data, there's less because a change has happened, like a global pandemic, or perhaps there's been, I know in one of the samples it talks about policy changes and there's less staff, and you're asked to compare the averages and did it change. Those questions are designed, I think, to kind of almost make the learner question if what they're doing is right. But the key thing with mean is stick with what you know, stick with that method, adding them together and dividing by how many you've got. So we already know the average for the 2019 data because we did it on the other part of this video. So I already know that the average here is 5. This one here is going to be exactly the same technique. It's going to be add them all together and then divide. However, this occasion, I'm not going to divide by 12. I'm going to divide by 9 because there's only 9 here. So back to that method. 3 plus 3 is 6. 4 and 5 and a 2 is 11. 1 and a 2 and a 3 is a 6. Add those 3 together. 11, 6 and 6. Do a column method if it helps. 1 plus 6 is 7. Add another 6 is 13. But I could have just gone double 6, add the 1. Carry that 10. 2 10s, so we get 23. And what we're doing is 23 divided by 9. Bit trickier this one, isn't it? If I was going to divide 23 by 9, I would do bus stop. Put the 9 there. How many 9s in 2? None. How many 9s in 23? There are 2, but we have got a remainder. So this is where this is going to come in now. How many were remaining? 5. So I'm going to carry that down here. How many 9s in 50? There are 5. Okay, so we're carrying another 5. 50. And what we've got there is a repeating pattern. Can you see it's just going to keep going? 5, 5, 5, 5, 5. So the answer to this question is 2.555 reoccurring. If they asked me to put it to 2 decimal places, then we'd become 2.56, let's call it. Okay, so did the average change? Yes, it did. And this is where statistical analysis comes in. This is where we start saying, okay, so why has that data changed? Average is very powerful for us to understand what's going on. Like I say, there's always contributing factors. Could be policy change, could be a pandemic, especially if it's salon appointments. Definitely less of those going on at the moment. But the key thing is just keeping that method the same and keeping tabs on how many people you've got to divide by or how many objects you've got to divide by. I hope you found this video helpful. I'm going to do another mean video on grouped data, which is something we see on exams. If you want to have a watch of that one, join me next time.